question today, people. I take the question number 57 in the tute. Question number 57 in the tute. Right, question number 57. And remember, this week I paused the tutorials, trigonometry 1 and trigonometry 2. The two tutorials I will post to you. I think everybody has given the correct postal address. So that only I'm going to post most of the time. By the next week, before your next class, you will be getting these tools. Okay. Right. Now we are given ABCD is a rectangle with AB 2 simple A and AD simple A. Sorry. Right. ABCD, people. Right, this way. It's a rectangle ABCD. I'll take this as our A, this as our B, this as our C, this as our D. It is a rectangle, therefore each interior angle is 90 degrees. And given that AB length is 2A, this length is 2A, and this length 2A, and people, this BC, this AD is simple A. This is simple A. Right? The midpoint of BC and CD, midpoint of BC is E. Midpoint means E bisects this BC. And if F is the midpoint of CD, F is here midpoint. This length and this length being equal. The unit vectors along AB and AD are I and J. Along this AB direction, unit vector simple I, AD direction, unit vector simple J. Right. Now, since this is a rectangle, you know opposite sides are equal and parallel. Right. Now, if the lines AE, BF, people, that's really a printing mistake. AE and BF should be there. Right? AE and BF are the straight lines AE and BF. AE is this. AE is this. BF is this. They intersect at P. Right. When lambda and mu are scalars, show that AP in two ways. But AP vector, people asking to find in two ways. Yes. First way is AP equals lambda times 2AI plus A by 2 times J. Second one is 2AI plus mu times minus AI plus AJ. Yeah. People, how to write this VE vector? This length is, people, a by 2. This length is a by 2. Huh? Right? This length is a by 2. People, give me 1 second. Right. Now, people, this BE is a by 2. BE direction, B to E direction, unit vector is J. So then you can write BE vector. How to write, people, BE vector? BE vector is equal to B to A distance is a by 2, alone B to E direction unit vector is J. Okay. And what is AB vector, people? AB vector is equal to AB length times A to B direction unit vector I. I. Okay. Then you can very easily find AE vector, people. You can very easily find AE vector by the triangle law of vector addition. By the triangle law of vector addition. People have tried that AE vector. AE vector is equal to AB vector plus DE vector. Okay. Then AE vector you can write, people, AB vector 2AI plus DE vector A by 2 times D. Okay. This way we can write. But people, you know, this AP vector and AE vector are on the same line. This AP vector is the shorter vector. Then this AP vector we can write as a multiple of AE vector. That's in the sense AE vector we can multiply by a real number whose value is less than 1. Then we get the shorter vector AP. Understood, people? So therefore, by multiplying AE vector by a suitable real number, we get this AP vector. The real number that we use to multiply this AE vector, here we take as lambda. Then you might say, how do we take that as lambda? Well, there we are given lambda and mu are scalars. So you might ask, what if we use another letter for this lambda? Never mind. Never mind. But since we are given lambda and mu, people, though you that separate any other letter you use there, what if we use lambda? That's also correct, no? Yeah, so then we can write, but we can write, people, AP vector is lambda times AE vector. Then substitute for this AE is AP vector is equal to lambda times 2AI plus 2 by 2 D. This is the AP vector. Okay. Secondly, another form asking for this AP vector. People, the next form for the AP vector, where we can write like this. I am going to first find this BF vector. How to write BF vector, people? By the triangle law of vector addition, BC plus CF is the way of writing BF vector. Now, suppose we found that BF vector. You know, this BF vector and BP vector both lie on the same line. Therefore, you can write this BP vector as a multiple of BF vector. That means since BP vector is shorter vector, to get that from BF vector should be multiplied by a value which is less than 1. You know, when we multiply something by a value less than 1, the final answer is less than the previous initial answer. Now, for example, 10 people is the original value. We multiply this by 0.1. What is the answer? Answer is 1. See here. Now, before multiply, this is bigger. It is multiplied by a value which is less than 0 and 1, right? That is not less than 1, or in other words, line between 0 and 1. Because the answer is less than this initial value. Like that, BF is a longer one. By this longer one, if we need to take the shorter one, people, the longer one should be multiplied by a value which is less than 1. In other words, between 0 and 1. This time to find BP vector, BF vector should be multiplied by a scalar. That scalar I am going to assume as people mu. Then this BP I can write as mu times BF. Now people, we know BP vector. Then AP vector you can write how? A B vector plus B P vector. Then the second answer is coming. I think you can take this answer, right? Right. Now start, people. We'll do together. Can write BF vector. BF vector you can write, people, BC vector plus BF vector. Right. How to write, people, BC vector? B to C vector. The length is E. B to C direction unit vector is, people, J, no? AJ. AJ. CF vector. C to F length is A. Half of A, we know. A. People, what is the unit vector in the direction C to F? In the opposite direction, this way, unit vector is I. This way, unit vector is I. Then opposite direction, minus I. Right? Minus I. Okay? Now you can write BF vector, people, minus A times I plus A times A. BF vector. Now BP vector you can write as a multiple of BF vector. Right? Now BP vector you can write mu times BF vector. This way you can write mu times BF vector. Right now? Mu times BF vector. But BF vector here we have found. We can write BP vector is equal to mu times BF vector minus AI plus AB. BP vector is okay. Now, people, again, by using the triangle law of vector addition, you can write AP vector as how? A B plus B C. A B plus B C. Therefore, AP vector you can write A B vector plus B C. A B vector, people, you know the length is 2A. Along that direction, the unit vector is I, then 2AI, right? is nothing but 2ai plus bp vector is this. It is the next answer asking now people. Mu time minus vi plus bp. This is right now. This is how we take people that answer. Now what is asking next? Hence find lambda and mu, obtain AP-PE ratio and BP-PF ratio. Right. Now, to get the final answer, people, we need this relation and this relation. Okay. These two relations we need. So then I'll write them at the side here because I need to erase this. That AP vector is equal to lambda times AE vector and BP vector is equal to mu times F vector. Right. Now, this people AP vector we have found in two ways. Here, AP, here, AP. Then the right hand sides must be equal. Okay, right hand sides must be equal. Right. So then we get now equating AP vectors this one should be equal to this right hand side now. Lambda times 2ai plus a by 2j is equal to people this. Okay, this one 2ai plus mu time minus ai plus aj. This is right. Okay, now you can equate people in the left and right the coefficients of I and j unit vectors. Right. So now here I am going to first equate coefficients of unit vector I on the both sides. People, when you remove the brackets, what we get here? We get 2a into lambda times I. Then the coefficient of I mean, except that I the rest part before it is called as the coefficient of I. Then what do you get when you remove the brackets? Lambda times 2a. What is that? Lambda multiplied by 2a means 2a lambda. Next one is I. Then the coefficient of I going to be 2a lambda. Left hand side. Right. On the right hand side, we have I here. Another I is coming by multiplying this mu. Then here coefficient is what, people? 2a. What is its sign? Plus. Here what do you get? Plus and minus minus. Mu into a into I. What is the coefficient of I? Mu a minus mu a. Now people, you can cancel this a in the left and right. Bring this mu to this side. Here we have 2 lambda. Once you bring this side, we get plus mu. This equal, this is 2. Let us take this as number 1. Because there are 2 unknowns, no, lambda and mu. Then we should have 2 equations involving lambda and mu. The other equation involving lambda and mu we can take, people, by equating coefficients of j. Yeah, Now, once we equate the coefficients of j on both sides, left hand side, when you remove the bracket by multiplying this lambda, what do you get? Lambda times a by 2 times j. Lambda into a by 2 into j. What is the coefficient of j? Lambda times a by 2. Lambda times a by 2 is the coefficient of j. That should be equal to right hand side j coefficient, that is coming like this. Mu times a j, mu a plus mu a. Here also this a and a you can cancel down. We can use people here the cross multiplication. Lambda is equal to 2 mu. This is the second equation number 2. Now we have two simultaneous equations. People. Right. By solving these two simultaneous equations, we can find lambda and mu. How to find lambda? People, this lambda here, I can replace by this lambda. Lambda is 2 mu, no? Then we can write by 1 and 2. By 1 and 2 means here lambda is 2 mu, but this lambda only here we have. Then for this lambda, I can substitute the value 2 mu. That's the meaning of by 1 and 2. 2 times lambda. Lambda is 2 mu. Another mu is here. Is equal to 2. 2 and 2 make 4 mu plus mu. What is that, people? 5 times mu equals 2. Then you can subject mu 2 divided by 5. Mu is this much. Now we need to find lambda. By number 2, for the mu, we substitute the answer of mu, 2 by 5. We'll put 2 by 5 here, then we get lambda. Lambda is 4 by 5. Now you can write, people. Now by number 2, lambda equals 2 times 2 multiplied by mu. Mu is 2 by 5, no? 2 divided by 5. So then we get lambda as what? 4 divided by 5. So this is the value of lambda. We found, people, this lambda and mu both. Okay. Now what is asking next? Asking, people, finally APPE ratio. Now I am going to use AP vector is equal to lambda times AE vector. That we use now, people. Right? That we use. We have written down this before, right? Now, once we eliminate the vectors here, we know when two vectors are equal, left hand side and right hand side, the sizes should be equal. Then we can write it how? This implies. What do you mean by implies? This relation gives us what? When two vectors are equal, people, the left hand side and right hand side are equal in sizes, no? What is left hand side size? AP length should be equal to lambda times AE length. Okay. But what is lambda, people? 4 by 5. Then you can write, take this AE to left hand side denominator. AP divided by AE is lambda. Lambda is 4 divided by 5. Okay. Now, our AP AE means this line, no? APE. Then I am going to draw that APE line. Here A we have, here P we have, here E we have. Now, what is understood by these people? When A to E length is 5 units, that means from here to here, the whole length is 5 units. A to P is 4 units. A to P is 4 units. That means when AP is 4 units, A to E 5 means people PE should be 1. A to E 5 units, A to P 4 units. Then P to E should be 1 unit. Then we can write AP is to PE ratio. Therefore, you can write AP is to PE ratio is 4 is to 1. 4 is to 1. That way we can answer it. Okay, no? Right. I think you could understand that well. So likewise, you can write this next answer asking BP PF ratio. BP-PF ratio, you can obtain people BP-PF ratio by using this relation. This is also another relation we have in our working, right? Yeah. Now we'll see how to take that one. Well, that we are here. Now I can write also BP vector is equal to mu times BF vector. When two vectors are equal, you know, left hand side and right hand side, the lengths are equal. This implies a BP length is equal to mu times BF length. Bring this BF to left hand side denominator. Then we get BP divided by BF is equal to this mu. Even mu, we know it's 2 by 5, no? Then we can write 2 by 5 here. Now, I can take this ratio. This is our B. This is our P. This is our F. Right, here. B to P, 2 units. B to F, 5 units. B to F, 5 units. Therefore, P to F should be 3 units. Now we get people BP is to BF as 2 is to 3. So we can write, therefore, BP is to PF is equal to 2 is to 3. So this is how people, we complete that question. We complete that question, right? Okay. People, now you should do these questions as homework again, people, right? Huh? Because I don't know whether you do this question alone or not. No, sometimes you might be copying everything on the board. If so, people, once you continue like that, your copying ability will be highly increasing. Okay. Improvement of the copying ability not worth at the examination, people, right? Because you are not allowed to copy at the examination. So therefore, improving the copying ability useless, right? Therefore, you have to work out at the same questions, right? Okay. Now, people, I'm coming to another new part means new topic in the same lesson, right? This theory, people, now I think you have done in physics. You have learned about something about forces. People, in applied maths lesson syllabus, we have another huge lesson as off-planar forces. We will discuss that lesson in detail because that is the backbone of the applied maths. Very important and very long lesson. Understood? In applied maths, for 5 or 6 lessons, the knowledge of the corporate forces we need. In physics, I think you have learned a little bit, or your OL knowledge also sufficient in this case to discuss this part. The whole lesson, coupling forces, I'm going to start after another 2 or 3 lessons. Till then, in order to cover up that part related to vectors, I use this time. Otherwise, after finishing this lesson vectors, if I try to do this part, I don't think that we will get a chance. Okay, right. Don't worry, people. We can, of course, very easily manage this. Now, I will just explain, people, a force. I'll take 5-10 minutes to explain this. Then very easily you can absorb these things. Sometimes you have not done this in physics, but never mind, people. We need a little knowledge regarding the force in this case to understand. People, now you know a force. Force means what, people? It is an action. When we, of course, implement that action on an object, if the object is stationary, object begins to move. If the object is already moving, if we do this action called as the force, the direction of motion of the object changes or its velocity changes, right? Its velocity changes. Right. Now, you know, usually we can apply a force. For example, suppose this is an old car. We push this old car. Then we say we apply a force on this old car. Because of the action of this force, people, that stationary old car begins to move. Then push we applied on the car is the force. Is the force. That force is measured in SI units, Newton. Okay. Right. Now, people, suppose this way a man pushes this car. He will apply particular force. Suppose 10 Newton force is applied. This is A. Another guy supporting him to push this same car. Say he is B. Then he also applied like 8 Newtons. Both this A and B push this car to the rightward with 2 forces, 10 and 8, to the same direction. People, finally, both this A and B will give a final effect to the car. It is a force. People, its size is, since the both forces are acting to the same direction, the total force acting on the car is 18 Newtons. This 18 Newtons is called as, people, the resultant force of the two forces, 10 and 8. 18 Newton force is called as the resultant force of this 10 and 8 forces. So therefore, people, resultant force means when two forces act, two forces or more than two, when two or more forces act on an object, because of the action of those forces, finally this object will get a particular effect. That final effect is a force with a particular magnitude. That object will feel a force is acting on it. That single force the body feel acting on it is called as the resultant force of that two or more forces. Understood? You know this already. In oil science, we have learned this. Now, people, when we need to find the resultant force of two forces which are not acting in the same direction. There's a method, right? When this way people say 10 Newton force act, this way people 8 Newton force act, suppose the angle between them is 60. This is that object. People, there is a method of finding this resultant force. That method is called as Parallelogram Law of Forces. This parallelogram law, verification of the truth of the parallelogram law, you will do one experiment in physics. In physics lab, you can prove this. I'll explain that later on once we do that corporeal forces lesson. I'll tell you what is this parallelogram law of forces. People, in this way, when two forces act on an object, the single force which come into the object known as the resultant force of these two forces is found, people, by drawing a parallelogram. That parallelogram law of forces says to represent these two forces, draw adjacent sides of a parallelogram. The lengths of the sides of the parallelogram are equal to sizes of the force. Then I have to draw this way 10 centimeter long line segment to represent this 10 Newton force. There my scale is what, people? 1 centimeter denote 1 Newton force. Subject to this scale only. Now I am going to draw. Then by measuring this angle to be 60, because the angle between 10 and 8 is 60, no? Another 8 Newton force here we have. Subject to this scale, I must draw 8 centimeter long line segment like this. Now we have what? Two adjacent sides of a parallelogram. That two adjacent sides of a parallelogram are represented the two forces 10 and 8 Newtons acting on this particle. Now the parallelogram law says, people, complete this parallelogram by drawing the other two sides. Complete this parallelogram by drawing the other two sides. Now draw the diagonal. Now draw the diagonal which is passing through the point of intersection of these two forces. This is the diagonal. Then by the length of this diagonal, we get the resultant force of these two forces. These two. The direction, force is a vector now, people. It has a direction. The direction is given when we put the arrow going out from this point along this direction of the arrowhead, the direction of the resultant force lies. That is the, people, that is the parallelogram law of forces. People, now I will give you another idea here. Right? Amendment. Yeah. This is the parallelogram now. Yeah. Then this force is 10 Newton. This is 8 Newton. This will give the resultant of this 8 and 10 forces. This parallelogram, people, this side is equal to this side. These two sides are parallel. Then when we put this arrow to this direction, then this 8 Newton force, it is a vector. That 8 Newton force we can represent by this side also. Because why? These two sides are equal, parallel. We have put the directions of the arrowheads to the same direction. Then this 8 Newton force only come in by this side. All right. Now, people, I am going to erase this. Still the same diagonal earlier we had available. Now, people, just apply here A, B, C. Now, what is A, B? A force. Force is a vector. A, B vector is this. B, C vector is this. Then this A, B vector represents what, people? This 10 Newton force. Now, B, C vector represents 8 Newton force. Now, people, when we apply triangle law of vector addition to this triangle ABC, AB plus BC will be equal to what, people? AC. But people, earlier we said, by this AC, what we get? We said AC gives us the resultant force of the two forces 8 and 10. And then AC gives what? Resultant force. Resultant force. Resultant force of 8 and 10 Newton force. 8 and 10 forces. People, then do you get particular idea by this relation? Here, addition of two vectors. In this case, vectors are two forces. People, then adding two vectors, we get single answer, no? By adding two vectors, according to this illustration, people, what kind of data you get? By adding two vectors, really, we find single vector as answer. So what is the meaning of that single vector we get as our answer? People, it is the resultant vector. What is meant by resultant vector? Instead of that two vectors, the single vector we can use. If that two vectors are really forces, by adding two vectors like that, the single answer we get is nothing but the resultant force of that two vectors. Therefore, people, when we say like this, when we add two forces, right, by using the triangle law of vector addition, the same thing we can write, people. Vector sum, this is called as vector sum. Here, this is a vector, no? This is a vector. Summation here we have. Vector sum of two vectors. Vector sum of two forces. Vector sum of two forces will give what, people? The resultant force of that two forces. Understand? Vector sum of two forces will give, people, the resultant force of that two forces. That is, well, obviously, you can understand by this illustration. That is our theory part. Understood? So now, people, see here, if we have, suppose a force, it is F1. F1 is 2I plus J. Now these forces lie via OXY plane. People, what do you understand by this F1 force? How do you understand this F1 force? Yeah, if I construct this way, OXY Cartesian coordinate plane, you know, along this x-axis the unit vector is I, y-axis the unit vector is J. Then what do you mean by this 2y plus J force? That force is F1. It has two components. One is in the direction of I, 2 units. This direction, 2 units force. J direction, here coefficient of J is 1 more. This direction 1. These two forces are perpendicular to each other. then this kind of positive x direction 2 units, 2 Newton force, positive y direction 1 Newton force. Single force has 2 components. Such force only people here this denotes. Right? Suppose another force we have F2. It is I plus 2j suppose. Then what is that force? It will have the rightward direction. I coefficient is 1, 1. J coefficient is 2. Right. Now suppose people this way 2 forces act simultaneously on an object. Then finally, because of the action of these 2 forces on that object will get a resultant force. Now people tell me how to find the resultant force. Yeah, add these 2 vectors. Add these 2 vectors. How? F1 vector plus F2 vector. We put here the underline this line people to say these 2 are vectors. Then we need to add 2i plus j. To this we have to add F2 I plus 2j. Tell me 2i and I is what people? 3i. J 2j 3j. Then what is this? The resultant of these 2 is 3i plus 3j. Then when this way 2 forces act on an object people, the object will feel the resultant force of that 2 forces. How people? Rightward direction 3 units, 3 Newton force, and upward direction 3 Newton force. The object feels like that. Okay. Now people, if we need to find really the final single magnitude of the resultant force, that means the modulus of this vector is the size of that resultant force. People, last week we learned when we have a vector which is expressed involving I and j unit vectors, how to find the size of that vector. We said size means modulus. Modulus, the magnitude in other words. How to find the magnitude of this kind of vector? We said people, square the I coefficient, square the j coefficient, and add them up and take the root. This is how we find the size of a vector which is having I and j. Then people simplifying this 3 squared 9, 3 squared 9, 9 plus 9 is 18, square root of 18 is the size of the force. Okay, people, if you can manage up to here, that's enough at the moment to do 2-3 questions under this part, right? Thereafter, you will furthermore realize this truth of this theory is when we start with the cooperative forces. I think up to here, you could understand a little bit. That is enough to work out some few questions we need. Okay, right people, now we'll write one sentence like this. Write down like this. Write down some heading like this. Resultant vector of some vectors. 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 Write down this way. Few sentences. Write down. When 2 vectors are added, when two vectors are added, the answer is another vector. The answer is another vector. Write down the meaning of the answer vector. The meaning of the answer vector is that it is the resultant vector. It is the resultant vector of the two vectors added. Of the two vectors added. Write down. If the two vectors added, are two forces, then the answer vector gives the resultant force, of the two forces. Okay, people. Right. Right. Now we'll take people only 2-3 questions. Right? Yeah. Write down like this. As a question, write down. Let F1 2y plus j, F2 3y plus 4j. Then find the resultant force, then find the resultant force as a vector. As a vector. Then find the resultant force as a vector. Also find the size of the resultant force. Also find the size of the resultant force. Right. We know people. Yeah, how to find the resultant force? Resultant force is what, people? F1 plus F2. Huh? We have to add these two vectors. Right, people? People, now don't get confused in this case. You know, when we add 2 and 3, directly we write as 5. People, these 2 and 3 are not vectors. They have only sizes. This is called as a scalar sum. Scalar sum. Only the sizes we consider in adding them. But this idea is different from adding two vectors. People, when we add two vectors, not only the sizes of the vectors, but the directions also we consider before adding. Therefore, sum of two scalars and sum of two vectors, they have different meaning. Understood? Right. Then meaning of sum of two vectors mean what, people? Instead of that two vectors, what is the single vector we can use to get the same effect? Understand? Okay? Yeah. So now here, how to add this resultant force? Right. F1 2y plus j. To this we have to add F2 3i plus 4j. Here 2i, here 3i, people. 5 times I. Here 1j, here 4j. 5j we get. Okay, no? So this is the resultant force. I'll use the notation capital F here to denote the resultant force. People, first case, find the resultant force as a vector. Here, this is the resultant force as a vector. Then how to understand this 5i plus 5j? I means rightward, j is upward, see? I is along the x-axis, j is along the y-axis. Then to the direction of x, 5 Newton, to the direction of y-axis, another 5 Newton. They are the components available of the force. Right. For such force, people, we can find resultant force, the size of the resultant force. The size of this vector we need to find, or modulus of this vector. Size means modulus, no, or magnitude. All are having the same meaning. Modulus, size, magnitude, all three have the same meaning. That is the size. How to find the modulus of this vector? We know that one. Last week we learned I coefficient perfect square plus j coefficient perfect square root. So therefore, size of the resultant force can then be found. I coefficient is 5 squared, j coefficient square means 5 squared. Add them up and take root. Then you can write size of the resultant force. Size of the resultant force. is equal to people 5 squared plus 5 squared root. This is people 25. This is also 25. It is 50, right? Then you can write 50. You can write people 2 into 25. You can take here root of 2 and root of 25. But root of 25 means people 5, no? Then we get the answer as 5 root 2. This is the exact size of the resultant force, right? Right. People now, since we don't know much about this resultant force, we'll discuss more sums involving vectors after learning some theories under coupling forces. Here I include this idea. At the moment, if I give you this idea, people, that occasion we discuss the coupling forces, and there when we discuss the questions related to these vectors, very easily I can give you this idea. Okay. Actually, now some questions available in the tutorial related to what these questions, this theory, but don't go to work out right now them. They are containing taking moments and all. I think I am sure that you can, you know about moments and everything. You might have learned that in physics, but people, that is not sufficient for me. I must teach you the moments and everything, so that according to my pattern, to practice you or to formally you. Okay, so then I keep that question discussions in the future to work out those after learning something, some theories in coupling forces in detail. Okay, and not only people that one, and this some questions available here. Subject to differentiation question also. That means another few math lessons called as calculus, right? That knowledge also you need to work out some questions in this tutorial. Okay, so at the moment you can't do them. So then you might ask, why did you put them? People, people, they work harder. Before the A-level examination, one day, they will work out all the questions in the tutorial. At the moment, you can't do all. Then sometimes you keep the rest questions to do in the future. The student, they do the tutorial questions again before the examination. Definitely will go through these questions. Understand, people? Then that occasion, all types of questions he will have done before A-level examination. That's why we put like this. Okay, otherwise, people, you might understand, if I don't put this kind of questions, our vectors means this solve. Oh, very easy, no? Every questions in the tutorial we could do, no? That idea you get. But if you see somewhere this kind of question, then only you say, oh, these are harder questions. Or our teacher, he hasn't done these questions. He has done partially. That idea you get. Now you know, people, that kind of questions available. At the moment, you can't work out that. Right now, you can't work out. Then you have this kind of questions available in the future. One day before going to exam, you should be able to work out this kind of questions. That idea now you have. Therefore, people, you have idea that some more things available to learn in the lesson. Okay, people, right? So therefore, you can get rid of those unnecessary feeling coming once you see that kind of question somewhere, because you know something we have to learn. Otherwise, people, what you do, you will find a particular doubtful situation. Whether you can't do, I haven't been taught you. You have been taught by me. So that kind of things come in, people. That is very dangerous, right? So then we discuss those questions later, right, people? Now, next thing I am going to do today is this, right? Now, vector equation of a straight line. People, in the syllabus, This thing I am going to discuss now, of course, not mentioned as vector equation of a straight line, but the same thing they have used in another form. When you go to the past paper sums and when we discuss the past paper sums in the future, you will realize the same thing only they have given without using that name, vector equation of a straight line. Then people, today heading is, write down, vector equation of a straight line. Write down heading as vector equation of a straight line. Vector equation of a straight line. Vector equation of a straight line is the heading. People, now let's see what is straight line. When I consider people this way, x-axis and y-axis, let this be the origin. When I draw this way a line, I'll take its equation as y equals 2x plus 3. This 3 is the intercept. Intercept means, people, this height denoted by letter C. This 2 is the gradient. M. Gradient is defined to be if this line makes an angle with the positive x-axis in anticlockwise, if that angle is theta, gradient means the tan of this angle theta. Tan. People, this is called as the equation of the straight line. Equation of the straight line. Y equals 2x plus 3 is the equation of the straight line. People, what are those x and y in the equation available? X and y, people, are, take any point on the line. I'll take this point as P. This point P has two coordinates, x coordinate and y coordinate. What is meant by the x coordinate? When I drop a perpendicular from this P on x-axis, this length only the x coordinate of the point P. People, what is y coordinate of the point P? This height. That x and y coordinates of any point on the line, only this x and y. Then what is meant by the equation of the straight line? Equation of the straight line means, people, the general relationship between x coordinate and y coordinate of any point on the line. Understood? The equation of the straight line mean what, people? The general relationship, common relationship between x and y coordinates of any point on the line is called as the equation of the straight line. People, now, in other words, take any point on the line, multiply x coordinate by 2 and add 3 to that, then we get of the same point y coordinate. That's the meaning of the equation of the straight line. Now people, see here, this way x and y coordinates we can consider if we have x-axis and y-axis. If we don't have x-axis and y-axis, can we consider that x and y coordinates? No, not anyway. And then suppose, people, I am going to erase this x-axis. When we erase this x-axis, people, we won't get x coordinate. Right? Are there x coordinate not available here? This x also we don't have. We erase y coordinate. y axis, then this y also not available. This also not available. Now see people, the early line is still available. The early line is still available. Right? And earlier O, origin available. Now no longer we can write x and y in terms of x and y. No longer we can write the equation of the line because no x and y. Then that way we can't give an equation to this line. Now suppose this O is the vector origin. Right. Now people, earlier on the line, if we consider a point had x and y two coordinates. Now no x and y axis. Instead of that two axes, now we have vector origin. Earlier, when we have people x and y axis, we could give x and y coordinates of any point on the line. This time no x and y axis. Now people, this time we can give for any point not x and y coordinates, but people for any point now we can give position vector. Why? Because we have vector origin. What is that people? This vector. In the earlier case people, when we change the point on the line, x and y both coordinates changed. Now this time no coordinates to change. This time when we change the point on the line people, what will change? The position vector will change. Understood? Now people, vector equation of the line mean we are going to obtain a general equation that gives us the position vector of any point on the line. What is this relation? The common relationship between x and y. What are these x and y? X coordinate and y coordinate of a point. Now we don't have x, y, no. Then what we have? Position vector. Then take this any point P. If I take its position vector is R, I am going to obtain a common equation which will give this position vector of the point P. That is called as what? The vector equation of the straight line. Very simple idea. Early xy, now we don't have xy, instead of that we have vector. Now such vector is called as the vector equation of the straight line. Nothing else. Okay? Right. Now people will take the heading we wrote already. I'm going to take people the first one like this. Suppose this way we have vector origin. You know, at the vector origin, position vector is null vector. Suppose this way a line we have. On this line, another 2 points available. Suppose first point is A, the other point is B. Relative to this O, suppose the position vector of point A is simple A vector, that we can write like this, or here also we can write it simple A vector. O B vector. Right people? I'm going to take position vector of B, no, I'm going to take that simple B vector. This is simple B vector. All right. Now our straight line is passing through 2 points, capital A and capital B. The position vectors of capital A and capital B people, simple A vector and simple B vector. Then our first next part of the equation of the line is people, the equation of the straight line passing through the points A, B. with position vectors simple A and simple B. That is our next heading. No need to write that heading, will write that as a sentence. Right. I don't like this. Consider a line simple L, a line simple L passing through the points capital A and capital B with position vectors simple A vector, underline simple A vector and simple B vector, underline simple B, respectively. You will draw this diagram. Right. Okay, now people, if we need to take the vector equation of the line L, we have to take any point on the line. Let's take that point as capital P, and let's take its position vector as simple R vector. Then to take the equation of the straight line L in vector form means for that simple R vector, we have to obtain an equation. That will be the equation of the line. Then what we do is this next, people. I'm going to take this way. Any point on the line as people, I'll take it like this, somewhere here. Any place we can take. I take this as P. Point P is any point on the line. Its position vector is, people, simple R. That means this OP vector is simple R. Right. This point P can be any location on the line. Like here, this point P with coordinates X and Y can be any location on the line. Like that, this P also can any place on the line. Right? So therefore, this R is a position vector that can vary. It varies, people, once the point P varies here and there on the line. People, these concepts at the beginning try to absorb. Sometimes not 100%. Actually, I can bypass this without teaching this. We can go ahead. In schools and in some other classes, people, they do like this. Why? When we, as a teacher, people, to teach this kind of things to small children, very difficult. Very difficult. Most of the chance, there's more chance the student will not be understanding this. Why? They have very simple points no to think. Then once I try to push this into your mind, people, sometimes I'll be fail. But even though I do this way, why people? These are very important in the future. If you at least heard about this thing, people, in a future day, you will suddenly accept this. Okay? Because when you go through the paper questions, people, this kind of theory is available. Right? So now, if I don't give new thing to your mind, people, you are always working with your existing knowledge, no? Then how can we say that you have an improvement? No, people. Therefore, these are a little bit difficult to absorb, but people, according to your possibility, capability, try to absorb. Maths means, people, not like a language, not like a poem, not like a short story. Short stories, people, we can very easily understand. Why? We can imagine that situation according to the story we have. Once we imagine the situation, if somewhere we can't understand, we can understand that thing by the imagining what? Story. Understand? Right? Now, when we people learn English in our childhood or another language which is not our mother tongue, people always, we had stories to read. I can remember even my childhood. One story there was Andre. People, now when we read the early sentences, we can understand and the story also come into mind. In the middle, people, some sentences we can't understand. But people, we can remember that story. Then we guess, according to the sentence, this should be the thing in use. Right, people? Like that. Sometimes you can't understand 100%. But people, if you have at least heard this one, in the future day, you can accept that very easily. That's what we call as people, we learn. If everybody can understand everything, people, no need to come to this kind of class. Just reading a book, you can do. People, we must learn something like that. That we have to give some time to, a certain time we need to absorb everything. Then only we get solid knowledge. So therefore, people, these are not difficult. Today, this is new for you, but next day when you work out a question, you will definitely adopt this situation and work out the question. So that is how the behavior of our brain. So therefore, let the brain to take as much as possible. The other part, it will take after some time. Okay, right. Now people will write. We'll write, let capital P be any point on the line simple L, any point on the line simple L with position vector simple R, underline simple R, with position vector simple R, relative to vector origin O. Okay, people. Now we need to obtain a relationship for R. That one we can write like this, people. A to P vector, A to P vector, A P vector. We can write, people, T times A B vector. Am I correct? A B vector is this. A to B direction and A to P direction same. AB vector is the long vector according to this diagram. Then AP shorter. This shorter vector we can write the longer vector multiplied by a scalar. This is correct, no? What is this t? T is a scalar. It is called as a parameter now. Why? It can change. Take in what? Different real numbers. Right. Where t is a parameter. Parameter means simply you can understand parameter as how people, a variable that can take different real numbers and it varies taking them. Right. T is a parameter. Right. Now tell me people, how to write AP vector? Second letter position vector minus first letter position vector, R minus A. T times, what is this AB? AB vector you can write second letter position vector minus first letter position vector like this. Now bring this simple A vector to right hand side. Once you take the simple A vector to right hand side, we get plus A vector. Plus A vector. Then what do you get? R is equal to A plus P times B minus A vector. Now, people, remove bracket by multiplying this T, TB minus TA, TB minus TA. Well, I can take this A and this A common now, take that A out. Here A means 1A. Here A and here A you can take out. Here this is 1, this is minus B. And this is TB. This is one way of writing, people, the vector equation of the straight line. Right? So then we'll keep this in our memory. People, then how to write the vector equation of a straight line when we are given two known points on the line with position vectors? Very easy, people. What is this R? Position vector of any point on the line. That known position vectors of the 2 points we write A, B. Any position vector we multiply by T, then the other one we multiply by 1 minus T. That's how we write, people, the vector equation of a straight line. So therefore, in order to write the vector equation of a straight line, what are the things we need, people? We need 2 points on the line with the position vectors. Then how to write the vector equation? R equals that 2 position vectors we write here and put in the middle plus sign, and 1 position vector you like multiply by T, other one we multiply by 1 minus T. That's how we simply write the position vector. Understand? Position vector of any point. It is the vector equation of the straight line. Right? So therefore remember this. Okay? Right. Okay, people, now. Right. People, take in your tutorial, question number 32, take its first part. Right. Read that one. I'll give 2-3 minutes and try to get that answer. Right. People, the first part. Position vectors of 2 points P and Q relative to a point O are simple P vector and simple Q vector respectively. Show that the position vector of any point on the line PQ is R. Right, people. Here also in this question, directly not given the vector equation of the straight line. That we not given. What is given there? show that the position vector of any point on the line PQ is TP plus 1 minus T times Q. People, that means instead of this A, there we have what, people? Q. Once you take this point A as Q with position vector Q and point B as P with position vector simple P, then this answer coming. So therefore, people, I am not going to work out that. Why, people? The same thing, no? Instead of AB, we use Q and P. Understood? Right? So therefore, I ignore that. Huh? Yeah. We'll go to the next part. Right. Now, next one, the position vectors of the points A, B, C, and D are A, 2B, 2A, 3B. Yes. Position vector A and C. All right. Here we have, suppose, people, vector origin O. Vector origin has the position vector 0, 0 vector. Point A and C. Point A has the position vector, people, simple A. Point C has the position vector, people, 2 simple A. People, if the simple A vector is OA vector, 2 simple A vector means what? 2 times of this, no? 2 times of this OA. That means OA should be produced from A in the direction O to A, the same length, to get what? The position vector 2A. And then OAC should be on the same line. Correct, no? O to C vector is 2A, O to A vector is simple A vector. Right. Next one, B and D, 2B and 3B. 2B and 3B. Right, we get 2B here, 3B here. Right, B and D. This is B, this is D. Position vector of D, people, 3B. Position vector of B is 2B. This is 2B. Right, this is 2B. Right. I take this from here, right? D3B. Right. Okay. Now, what is next? Show that the position vector of the point of intersection of AB and CD. AB and CD. We can join AB like this, people. AB we can join like this. And CD we can join like this. AB and CD, they intersect here. Suppose this intersection point as P, right? Then we are asked to find the position vector of the point of intersection of this AB and CD lines. People, you know, related to this vector origin O, the position vector of point P means, people, OP vector we need to take. We have to show in the question that OP vector is 2 times VB vector minus A. People, very easy. First of all, we'll take the equation of AB line, vector equation of AB line will take. Second, we will take vector equation of CD line. You know, people, how to write the vector equation of a straight line? To write the vector equation of a straight line, we need 2 points with position vectors. Then how to write? T times any position vector out of that 2 we like, plus 1 minus t times the other position vector. That is how we write the equation of that line. Okay, all right. And then we will start like this. Equation of AB line. How to write, people? R equals, on AB line, what are the 2 points? We have A and B. What are the position vectors? Vector A, 2B. Then we write what? T times A. Then next one, 1 minus T times what, people? Other position vector, 2B. If we change it other way around, also correct. What is that, people? T times 2B vector plus 1 minus T times A vector. That also correct. All right. So then we can write this as how, people? R is 2TB plus 1 minus T times A vector. Right. This is the vector equation of the straight line what? Straight line AB. Right? Okay. Next one, we write equation of CD. Equation of CD. Then we write R equals, people, don't use the same T. Use another different one. Use another different letter. Don't use the same parameter. Okay. I use another one. I'll take that as T dash. T dash. Right? Then what are the 2 points? 2A and 3B, no? T dash times 2A vector plus 1 minus T dash times what, people? 3B vector. Okay, then here we get what? R vector 2 times T dash A. All right, here what, people? This 3 I can write like this. 3 times 1 minus T dash B. All right. This is the equation of CD. And now, people, we come to a very simple question. Now, suppose on this OXY plane, we have 2 lines. One is with the equation y equals 2x plus 1. Other one with the equation y equals minus x plus 3, like this. You know, this way 2 straight lines intersect. The intersection point is this, people. Well, this point, if I take as P, this point P has x coordinate and y coordinate. This point P has the x coordinate and y coordinate. X coordinate means when we drop a perpendicular to the x axis, this is the x coordinate. This height is the y coordinate. People, can you tell me how to find the coordinates of the point P? X coordinate and y coordinate. How to find? People can remember this way. To find the point of intersection in your all levels in graph lesson. I think you did this, right? Graph lesson. What we do? What we do, people, this. You know, at the point P, what is the height to this line? This. At the point P, what is the height to this line? Also this y. That means, people, the y coordinates of this line and this line at the point P are equal. Then what we do to find this x coordinate, what we do is this y of this line and this y of this line Since they are equal at the point P, we equate this right hand side. We equate that right hand side. Understand? Similarly, people, at the point of intersection, the position vector, right, of this point, which is on the line CD, and on the line AB, this point P lies on the line CD and on the line AB. Therefore, at the point P, this R and this R should be equal. Why? The point P lies on both lines. When this R and this R become equal, people, the right hand sides must be equal. Then we can equate right hand side. Once we equate right hand side, on left and right, we can equate the coefficients of simple A vector and simple B vector. Once we equate like that, simple A vector and simple B vector coefficients, people, we get two equations involving the parameters T and T dash. We will find either T or T dash. Suppose we found T, take in the terms of T and substitute in here and here. When you simplify, we get what? The position vector of what? This P. Why? That T value is the required value of the parameter which gives the position vector of the point P. That's the method. Okay, then we can write one sentence like this. Write down, at the point of intersection, of the two lines, at the point of intersection of the two lines, the position vectors given by the position vectors given by the equations of the lines become equal. Yeah. That means, people, this R and this R equal. If this left hand sides are equal, then right hand side must be equal. Understood? Right. Then we can equate the right hand side. This equals this. Therefore, people, we can write 2 times TB plus 1 minus T times A should be equal to, people, this 2 T dash A vector plus 3 1 minus T dash B vector. Now, in the left and right, people, equate the coefficients of A vector and B vector. A vector and B vector. Right. Equating coefficients of simple A in the left and right. Here this is 1 minus T. This is 2T dash. Then we get 1 minus T equals 2T dash. Take number 1. B vectors, people, here 2T. 2T equal to what? This 3 times 1 minus T dash. Take this as number 2. Because we need to find either t or t dash. Whichever you get, substituting that at the relevant place and simplifying of the equation, we get what? The required position vector at the point of intersection of that two lines. Okay, yeah. I think very easily we can find this t dash. How? I multiply the first equation both sides by 2, and the resulting equation we add to what? Number 2. Then how to write that one? Equation number 1 we multiply by 2. This one, and this one we have to multiply by 2. Then we get an equation. No? That one we add to what? Number 2, right? First equation multiplied by 2, and that is added to 2. Okay. Then how to do this now, people? This first will multiply by 2. 2 minus 2t. 2 minus 2t. That left hand side of number 1. We have to add that to the left hand side of number 2. It's 2t. Equals. Now, right hand side of number 1 multiplied by 2. What do you get? 2 and 2, 4t dash. Add the right hand side of 2 to this. What is that? 3 times 1 minus t dash. Right, people? This minus 2t and plus 2t you can cancel down. Then here we have 2. Here 4t dash. Remove the bracket by multiplying this 3. 3 into 1 is 3 minus 3t dash. Now simplify this. Take this 3 to this left hand side. 2 minus 3 come in. It is minus 1. 4t dash minus 3t dash is t dash. Right? Then we get, take this 3 to this side, it's minus 3. 4t dash minus 3t dash is t dash. 2 minus 3 is minus 1. It is t dash. T dash is equal minus 1. T dash is minus 1. Then the required value of the t dash which give the position vector of p is people minus 1. The t dash involving with this equation. Now once we put minus 1 for here t dash and here t dash and simplifying, people, you get r. What is that r? The position vector of the point p. If we found t, then that t we have substitute via here to get what the position vector of the p. By that way also the same answer coming. Understood? All right. Now substitute that, people, t dash figure via here and here, and simplify and take this r, that answer is coming. Right. Now you can write, therefore the position vector of p, what do you get? R equal t dash minus 1, 2 into minus 1 a vector plus 3, 1 minus 1 b vector. R vector is minus 2, a here minus plus 2, 3 into 2 is 6b. People take 2 out. 2 is common for this and this, no? Also take 2 out. Right, I'll first write this one. This 6 we have divided by 2, no? Then we get 3b. Take this 2 out, we get minus 3. So this is how we take the position vector of the point P. That is the asking answer. Right, people, question number 32, second part. Question 32, second part, you can do as homework. Do the same, similar question is there. Right. Well, now we'll come to the next part, right? Okay. Right. Now, people, the next part is vector dot product, right? Vector dot product is the next heading, right? You want a small break, people? Yeah? You want a break? Today I supposed to discuss the class another little time. You want a break like 10 minutes? Huh? Yeah? Right. Didn't take like 5 minutes enough. Take 5 minutes and come back to the class. I discuss the next part also today. Take only 5 minutes now, 10, 15, no? 10, 12. Yeah. By 10, 20, come back to the class. Right. Now, people write down the next heading as vector dot product. Sometimes this is known as vector scalar product. Vector scalar product. Right. Right. Now, people consider two vectors. We know when we hear the word vector, I told you at the very beginning of this lesson, you have to imagine a line segment along with arrowheads on that. Arrowhead on that. Suppose this A and B are two vectors, right? This way. Let the angle between them be theta. Okay. Now we define something called as vector dot product. Here the word dot is used to denote this product, people. We write it A dot B this way. People, now you know 2 multiplied by 3, it is 6, no? Grade 11 and in below grades, people, we multiplied 2 and 3 by writing multiplication sign like this. Now in A level, people, we write this multiplication sign putting a dot here. That dot is coming between 2 and 3 on the lower part of 2 and 3. If we write this dot in between, exactly midway somewhere here, people, that is 2.3. So therefore, this dot is put here. This dot also, people, has the meaning of this multiplication. This also 6. People, now in place of this 2 and 3, if we put A and B, two vectors with the dot here, right? This is called as A dot B. Its answer is, people, obtained like this. Its answer is obtained modulus of vector A multiplied by modulus of vector B multiplied by cos value of the angle between the vectors A and B. This angle theta is, people, an angle between 0 and 180. This theta can be 0. maximum value it can take is 5. 5 means 180. Then people, A and B are two vectors. Of these two vectors A and B, A dot B, A dot B, we define like this: modulus of A, size of the vector A multiplied by the size of vector B multiplied by cos theta. What is theta? The angle between the two vectors A and B. Then you might see over there that dot means 2 multiplied by 3, 6. Then why we write like this? Remember people, this is the definition. This is how we define a product called as vector dot product. This is how we define. Nobody can argue how. How could it be like that? No arguments. This is how it is defined. You know, people, you have a particular name, no? Can you argue with that name? How can I be like this? No, people, that is how your parents define you when at your birth. Like that, the first mathematician, he found this dot product of two vectors. He said like this: I am this guy, this kind of guy, I am the professor. I define something like this. It is called as vector dot product, denoted by A dot B, and it is given by size of A multiplied by size of B multiplied by cos theta. That's all. That's the definition. Then accept that. That's all. Understood? So this is how people we define A dot B. Right? So this dot people, we used there as a multiplication feeling, but that multiplication and this dot multiplication being two different. The reason is, people, here multiplication is in between two scalars. Here multiplication is between two vectors. Understood? So therefore, no need to think much. First accept this way when we write dot product between two vectors A dot B, its answer is given by modulus of the first vector multiplied by modulus of the second vector multiplied by cos theta. The right hand side between these values, we have the usual multiplication in day-to-day life we use. Why? Modulus of A means what, people? A size, real number. Modulus of B is what? A size, real number. Cos theta is what, people? A real number that can take a value between -1 and +1. Understood? So therefore, on the right hand side between these values, we have the usual multiplication because they are scalars. But in the left hand side, between A and B vectors, we have a dot. That is, of course, not named as any other way. It is A dot B, that's all. A dot B. Its answer is given by this. Understand? Right. Then first of all, people will define this A dot B. Write down like this. Let simple A vector, underline simple A vector. Let simple A vector, underline simple A, and simple B vector, underline simple B, and simple B vector. B, B. Any two vectors, with the angle between them, is theta, such that theta less than or equal to pi, greater than or equal to 0. Then draw this diagram. Only diagram, don't write this, huh? Only diagram with this theta less than or equal to pi, greater than or equal to 0. Don't write this one now. Right, we will now write down like this. Write down the vector dot product. The vector dot product. The vector dot product. The vector dot product of vectors simple A and simple B vectors denoted by A dot B, denoted by A dot B is defined as A dot B equals mod A times mod B times cos theta. Mod A mod B cos theta. Mod A mod B cos theta. Right. People, this is known as the vector scalar product because of this reason. The right hand side, this is a real number. It is a scalar. This is a real number. It is a scalar. This is a real number that can lie between +1 and -1. Then here we have the usual multiplication on the right hand side among 3 real numbers, among 3 scalars. When you multiply 3 real numbers, people, the final answer is another real number. That means a scalar. That means finally the answer of this A dot B is a scalar. That is why, people, this is known as scalar product. People, another product we have, that product also we learn little bit under this, that in our syllabus, people, that is just shown something like this available, but we just go little deeper in learning that next product. That product is called as, people, vector cross product. Vector cross product. It is denoted by this way, people, A cross B. It is denoted by A cross B. A cross B. Its definition is mod A, mod B, sin theta, and n also come in there. N is unit vector. Then, people, here this is a scalar, this is a scalar, this is a scalar. This 3, when you multiply, we get a scalar, but finally that should be multiplied by a vector. The product of scalar and vector finally give us, people, as our answer vector. So therefore this result is a vector. Then this is known as, people, vector product or vector cross product, that we learn little bit in our syllabus, people, when we were learning A levels, people, long before, because we are now all people know, right? In nowadays, people, we had what? Vector dot product, vector cross product, vector triple product, something like this we had. That is this A cross B dot C. Vector triple product we learned. But fortunately, vector cross product only the introduction, vector triple product not available in the syllabus, vector dot product only available completely in our combined math syllabus. So then you might say you are very fortunate. No, people, you are not fortunate. Because more beautiful places are these. When you go to the engineering faculty, when you learn electrical engineering, electronic engineering people, definitely this cross product, vector triple product, you have to use. Then you will learn them under maths in the syllabus. Now you have another maths part to learn where after entering the university. In them, of course, people, you will learn this because they are very important things. That means the things that we learned in nowadays at A levels, now you have to learn where at the university. In spite of the situation like this, people, more areas dropped from our syllabus to form what the combined maths. Then that should be very easy enough for the students, no? But still, majority of the students, they can't get at least S pass for A maths. Don't know the reason, right? So now compared to our syllabus, now combined maths, now people, in nowadays we had nearly 60 lessons, 60, but in your case, it's 28, right? But still people, and not only that, in nowadays we had 4 papers, 2 papers for applied, 2 papers for pure maths, but we have only 2 papers for both applied and pure. Now getting A pass for combined maths should be very easy now. What reason? Don't know reason. Reason is some occasions the reason is error in our education system, and sometimes as tuition masters we are also responsible for this. I am not, of course, participating for this one. The reason is people, most of the tuition masters, they do on the surface so that to keep the students in the class without going away. Thereby, they don't teach too deeper. Because of that, one reason I can explain like that. Other thing is, if we do more harder sums, people, most of the students, they give up the class. Why? They know their friends are going to very comfortable classes. Comfortable means what? Nothing to do. Only thing is to copy down the board, the thing available on the board. Very simple sums. Everybody can work out and get the answer. The master always keep you in the happy mood. Finally, people, examination only, the important one, there you will find more inconvenience than first time you give up the errors. That's what the really issue, right? Okay, anyway, people, I told that I am not in that category because whatever the number of students, whoever give up my class, never mind, I do my duty at best. That's why, people, we have this kind of survival. So therefore, you are fortunate in that point of view. If you can continue the class till the end of your till the A-level examination. Yeah. Okay. Otherwise, people, now see, half of the syllabus is removed. Only 2 papers. Now getting A pass means really easy. In nowadays, of course, we didn't have no YouTube, no internet, no books, right? No English medium those days, people. Right? Now, you know, science discovered originally by the English language, then more books published in English. Very rarely those books are translated into Sinhala. Using those books only, people we learn. But when you go to the internet, people, how many books available related to maths? How many YouTube clips? That means the clips you have to watch. You can watch many avenues now we have. Therefore, you should be able to get the A passes very easy, but still the situation is very worst. Reason we can't explain. Anyway, people, work harder, then achievement is there, right? Okay, then we can write this way, it is defined. Right, now we can just consider what is the geometrical meaning of this dot product, right? Right, like this. Geometrical meaning of vector dot product. Geometrical meaning of vector dot product. Geometrical meaning of vector dot product. Right, people, now I'll take like this. Right, this is the vector A. I'll take this as OA. Suppose this is vector B. I take that as OB. Let this angle be theta. I drop a perpendicular like this. Right. Now, A dot B I can write. A dot B. It is what, people? Modulus of A times modulus of B times cos theta. What is modulus of A? A is this vector. Here, this vector. Modulus of A mean, people, OA length. A is this vector, no? Then modulus of A means OA length. This is OA length. OA length multiplied by modulus of B, OB length, multiplied by, people, cos theta. Then this is nothing but OA multiplied by OB cos theta. This is the A dot B meaning. People, what is this OB cos theta? If I take this point as C, people, we can write cos theta like this, no? But what is cos theta? Cos theta is what, people? Adjacent side divided by the hypotenuse. Adjacent side is OC. Divided by the hypotenuse is OB. Use the cross multiplication to this end. Then what do you get? OB come in here, OB cos theta equals OC. OB cos theta is equal to OC. This gives us OC is equal to OB cos theta. Yeah. Here we have OB cos theta. Then for this OB cos theta, people, we can put what? OC. Then see what happens. Then we can write, then A dot B is equal to OA multiplied by this OB cos theta means what? OC. OA multiplied by OC. Right? People, what is this OC? What is OC? OC is called as what? The perpendicular projection of this OB on OA. Can you remember in trigonometry, we speak about this perpendicular projection. This way we have OP line segment. From the point P, we drop a perpendicular on this x-axis. Then this length is called as what, people? The perpendicular projection of this OP on x-axis. The same situation here we have now, people. From this point B, we drop a perpendicular on this OA. The perpendicular foot is C. Then this OC is the perpendicular projection of this OB on OA. Then this OC I can write perpendicular projection. OB line means vector B. The perpendicular projection of vector simple B on OA means what, people? On vector simple A. Understand? Okay, so therefore we can write A dot B how, people? OA, right? OA means modulus of A. Okay, people, right? Modulus of A multiplied by what? The perpendicular projection of simple B vector on simple A vector, right? Multiplied by perpendicular projection. Perpendicular projection of simple B vector on simple A vector. This is how we, people, understand geometrically the meaning of A dot B. A dot B. Okay? A dot B is what, people? Modulus of A multiplied by the perpendicular projection of B vector on simple A vector. Understand? Right. Okay. Right. Now there are some properties of dot product. Right? We'll see what are these properties. Right. First take down this and we'll go to the next subheading. Write down properties of vector dot product. Properties of vector dot product. Properties of vector dot product. First property, people will write A dot B is equal to B dot A. That means when we interchange the order of taking the dot product, people, the answer won't change. That's what it says. Right? It's like 2 multiplied by 3 is equal to 3 multiplied by 2. Something like that. Yeah. We can very easily prove, people, this. We can very easily prove this. How? You can write the proof like this. Suppose this is our vector A, this is our vector B, this is theta. How to write A dot B, people? A dot B is equal to modulus of A, modulus of B, cos theta. B dot A. B dot A is people modulus of B times modulus of A, again cos theta. But people, this mod B and mod A, they are two real numbers, no? You know, when we multiply two real numbers, though we change the order of multiplying them, people, the answer won't change. 2 into 3 is equal to 3 into 2. Then with that, I can write this mod A, mod B interchange in the order. I can write like this. Mod A, mod B, cos theta, like this. People, this mod A, mod B, cos theta by this A dot B. Then we started B dot A. This is nothing but A dot B. So this is A dot B. So what do you get? B dot A is equal to A dot B. Therefore, B dot A is equal to A dot B means A dot B is equal to B dot A. Understood? This is how we simply prove that result. Okay? Right. That's first property. That means people, when we need to take the dot product between two vectors, no need to worry about what? The order of writing the two vectors. Whether to write A dot B or B dot A, people, no issue, whichever we write, that's correct, because A dot B and B dot A being equal. That's first property, number one. Number two. Number two, people. Modulus of vector A perfect squared will be given by A dot A. That means if we need to find the perfect square of the modulus, perfect square of the modulus of a vector, that can be obtained by taking dot product of the vector with itself. Or we can write modulus of A, this one is the square root of A dot A. This way. Okay. This is also very simple proof, people. A dot A is equal to mod A, again mod A. People, between A and A, what is the angle? This is A. I draw another A on the same thing. So what is the angle between them? 0. Angle between the vector A and itself. No angle, people, angle 0. Angle 0. Cos 0. You know cos 0 is 1. Cos 0 is 1. Then we get what? A dot A is equal to mod A times mod A means, people, mod A perfect square into 1. That means mod A perfect square coming. Okay. So therefore we can write, this implies A dot A equals mod A squared means mod A perfect squared is equal to A dot A. Or by this we can take the mod A, taking the square root of right hand side A dot A, square root of A dot A. This is how, people, we take through that result. Okay. Right. We'll come to the next property, number 3. Right. Third property, write down. Number 3. Number three, write down the angle between two vectors. The angle between two vectors. The angle between two vectors can be obtained the angle between two vectors can be obtained by vector dot product. Right, people? Suppose this way, we have two vectors. A vector here, B vector here. This angle is theta, suppose. Now I am going to find this theta. That can easily be found like this, people. A dot B, we can write how? Modulus of A, modulus of B, cos theta. They take this both mod A and mod B to the left hand side denominator. Then A dot B divided by mod A times mod B is equal to cos theta. This equals cos theta means, people, cos theta equals this. Cos theta equals A dot B divided by mod A mod B. This way. Then theta can be subjected, taken equals to right hand side as cos inverse. Theta is equal to cos inverse A dot B divided by mod A mod B. This way. Oh, people, the same thing we can write right? Or we can write cos theta. A dot B divided by mod A mod B, no? A dot B divided by mod A times mod B. This one I can write further like this. A vector divided by mod A dot B vector divided by mod B. This way we can write. People, a vector divided by its modulus. What is the result? When we divide vector by its modulus, what do you get? We get the unit vector in the direction of the vector. Understood? So therefore, this A vector divided by its modulus is the unit vector in the direction of the vector simple A. That is denoted by, people, A hat. This way, A hat. A vector hat dot B vector divided by modulus of B mean B hat. What is B hat? The unit vector in the direction of the vector simple B, right? B hat. Then we can write cos theta like this. Then theta can be subjected cos inverse A hat dot B hat. We can write what is this A hat? A hat is the unit vector in the direction of the direction of the vector simply. We had the unit vector in the direction of the vector simple v. Right, people. Some few properties we have. We'll discuss them next Friday. Right? Then we can come to the last part, most probably next week, that the vector cross product, little introduction, and I take another 2 classes after next week class to discuss the overall question in common. Then we come to the past papers and then come to the end of this lesson. Okay, people, then we come to the end of the today lesson. Next Friday, we will continue from here. Okay, so then, good night to everybody. Do this part before the next day. Okay, all right.